inverse of ये सोन चलता है ना range of secant inverse of 1 plus cos square x, where this close interval bracket is having a greatest integer function. So let me start with the cos x. We know everyone that this cos x lies between -1 and -1 to 1, means a range of this cos x is -1 to 1. If I made squaring on both sides for cos, that makes you cos square, which lies between 0 to 1. If adding 1 on both sides, then 1 plus cos square x lies between 1 and 2. Now, by writing secant inverse on both sides, then what we get here, secant inverse x 1 less than equal to secant inverse of 1 plus cos square x less than equal to secant inverse of 2. So, the overall this whole function, its range is what here, this secant inverse 1 and secant inverse 2. A range of the whole one is stack. Domain of the following. Here domain of f of x where f of x plus 1 by x equal to x square plus 1 by x square. So let me start from here. Here f of x plus 1 by x equal to x square plus 1 by x square. Now for this we can write that one as f of x plus 1 by x, f of x plus 1 by x equal to x plus 1 by x whole square minus 2. So it is just like what here, a plus b whole square minus 2. So let me consider this x plus 1 by x as y, and f of y equal to y square minus 2. Now let me consider am greater than equal to gm. Let me take with the two conditions. One is what here, if x greater than 0, the other one x less than 0. Now if I start with x greater than 0 and take the condition am greater than equal to gm, x plus 1 by x by 2 greater than equal to x into 1 by x. So this x and that x both get cancelled. Send this 2 to that side. So what you get here, x plus 1 by x, which is greater than equal to. Similarly, now if x less than 0, here minus mod x plus 1 by minus mod x by 2, which is greater than equal to square root of minus mod x into 1 by minus mod x. These two get cancelled. Send these 2 to that side. So finally what we get here, x plus 1 by mod x greater than equal to 2. So mod x plus 1 by mod x less than equal to minus 2, because here minus if we send to that side, is greater than equal to becomes less than equal to. So we have x plus 1 by x greater than equal to 2. Let me consider that one as from first condition, mod x plus 1 by mod x less than equal to minus 2. So here we can write this part as x plus 1 by x greater than equal to, second one mod x plus 1 by mod x less than equal to minus 2. So from this we can plot that if we have this here we can say that x plus x always belongs to R. X always belongs to R. So cut kar do. So here we can say that this x plus 1 by x greater than equal to, okay, that is first condition, mod x plus 1 by mod x less than equal to minus 2. That is the second condition. From 1 and 2 we can say that R minus of minus 2 comma 2. So from here we can say that domain of small f of x, which is nothing but R minus of minus 2 comma 2. Okay, so the condition. So here f of x plus y equal to f of x plus f of y, that is, and given what here, f of 1 equal to 5. So we have to check that what is the concept of f of x, what type of function it is. So for this, let me replace x equal to y equal to 0 in above equation. Then f of 0 plus 0 equal to f of 0 plus f of 0. So we know well f of 0 plus 0 means again 0. So f of 0 equal to f of 0 plus f of 0. Both f of 0 get cancelled. So f of 0 equal to 0 we got. Now in place here let me replace this, put y equal to minus x. So f of x minus x, because in place of this y, here we are going to replace with what here, this minus x. So x will be same, here minus x to be replaced, equal to f of x plus f of minus x. We know x minus x means 0, so f of 0 equal to this f of x plus f of minus x. Now replace this f of 0 equal to 0. So what you now get, f of x plus f of minus x. This f of 0 means here, what I said here, 0 said. So let you replace 0. So finally f of minus x equal to this f of x, if we send to that side, that makes you minus f of x. Most of them knows this condition. What is it? Whenever if we have f of minus x equal to, this minus goes outside and into f of x. So such type of function called as odd function. Such type of function called as what here? Odd function. Okay. Here sin inverse x minus cos inverse x plus sin inverse of 1 minus x equal to 0. We have to find here x belongs to what will be the answer. So for this, let me start with what here is. Let me hold this sin inverse of 1 minus x there itself. Send these two to that side. So what you get here, cos inverse x minus sin inverse x. This cos inverse x can be written as pi by 2 minus sin inverse x. This minus sin inverse x will be as it is. So sin inverse of 1 minus x equal to this pi by 2 will be same. By adding these two, you will get minus 2 sin inverse x. Send this sin inverse to that side. So what you get here, 1 minus x will be like that. The sin inverse will be becomes what here, sine of this pi by 2 minus 2 sin inverse x. Next, 1 minus x of, when you hold this sine with this pi by 2, that becomes cos, and 2 sin inverse x will be as it is, no change in that. Now 1 minus x equal to cos of this 2 sin inverse x can be written as sin inverse of 2x into square root of 1 minus x square. 1 minus how much here? X square. So here sin, 1 minus 2 sin x cos x, that makes you what here? 2x, just like that. So like that we can write that. So 1 minus cos x equal to cos of cos inverse x of, I want to change this part is in terms of cos inverse x. So within that we'll have what here, 1 minus 2 x square. Now this cos and cos inverse both get cancelled. So finally what you get is 1 minus x equal to 1 minus 2x. Send this minus 2x to that side. This 1 and 1 get cancelled. So 3x square minus x equals 0. X of 2x minus 1. Now see, this x will be equal to 0. So finally x equal to 0. And 2, this 2x minus 1 equal to 0. That makes you x equal to 1 by 2. Now finally, what is the value of x here? Such individual 0 and individual 1 by 2. So second term, domain of the function f of x equal to secant inverse of 3x minus 4 plus tan inverse of x plus 3 by 5. So f of x equal to secant inverse of 3x minus 4 plus this tan h inverse of x plus 3 by 5 can be written as 1 by 2 into log of 1 plus x plus 3 by 5 by 1 minus x plus 3 by 5. So by solving this, we get that part as 1 by 2 into ln of this 8 plus x plus 8 by 2 minus x. Now let me consider each one and evaluate those, and we have to find what your function. So here 3 for secant inverse x, what we get here, limits will be other than minus 1 to 1 on either side of minus 1 to 1. So here what I'll take here, this 3x minus 4 1 thing as less than equal to minus 1, other one union 3x minus 4 greater than equal to 1. So by solving this, what you get here, x less than equal to 1 union x greater than equal to 5 by 2. What it means, this x will be what here, less than 1. So minus infinity to such close interval 1, because here equal to is there. Union this 5 by 3 to up to infinity. Greater than equal means starting from 5 by 3 and more than that. Now for ln of x plus 8 by 2 minus x. So x plus 8 by 2 minus x. So here whenever if you have log, this whatever g of x is there, that will be greater than 0. So this whenever if you have f of x by g of x, we can write like this. But here minus common there, that's what this greater than becomes what here, less than, because I kept minus and sent to that side. That makes you less than 0. Now what the roots we can get from here? One is what, minus 8, from here 2. See, let me pick what 1 by 1 numbers. This minus 8. Let me over there. After that 1 is there. Next 2 is there. And 3 by 2, 5 by 3 means what here? 5 by 3 means what here? 5 by 3. Here 5 by 3 I am keeping here. If I do division, that will be less than what here 2. Now what I am doing is here minus infinity to 1. See here minus infinity up to that 1. Okay. Next one 5 by 3 to infinity. See 5 by 3 and moves towards plus infinity. So what is the meaning of this thing? Minus 8 to 2. Minus 8 to 2 means see that is bounded within here. Means starting from minus 8 up to 2 is enclosed. Now here what are the like terms? Yeah, like terms are what here minus 8 to 1. The other one what will be 5 by 3 to 2. If I merge, that makes me x belongs to minus 8 comma 1 union 5 by 3 comma 2. This is the final solution. Thank you.